Welcome to First Grade Math Tools. In this math workshop, we will take a deep dive into what math tools, the manipulatives and the representations, we should use with our young mathematicians to impact their understanding of core mathematical concepts. We will explore why we should provide math tools for our students, what tools to provide, how, and when. Whether you are an educator new to teaching first grade, a homeschool parent teaching your young mathematician, or an experienced first grade teacher. Our hope is that this math workshop will provide the support and guidance for you as you teach your children mathematics. These are the 4 domain areas for mathematics for first grade: operations and algebraic thinking, number and operations in base 10, measurement and data, and geometry. Let's talk about why we should provide math tools for our students. We agree with this quote from Paul Halmas: "The only way to learn mathematics is to do mathematics." We believe that providing math tools for students to use in math class offers a wide range of benefits, transforming abstract mathematical concepts into concrete, understandable experiences. Many math concepts like addition, subtraction, place value, or algebraic equations are inherently abstract. Math tools provide a tangible way for students to see and touch these concepts, making them more concrete and easier to grasp and to remember. Providing hands-on experience helps bridge the gap between abstract mathematical ideas and real-world scenarios. Math can sometimes feel dry or intimidating. Manipulatives introduce an element of play, exploration, and interactivity, making math lessons more engaging and fun. Increased engagement often leads to more positive attitude towards math, fostering a lifelong love of learning and reducing math anxiety. Not all students learn in the same way. Manipulatives cater to kinesthetic, hands-on, and visual learners, providing multiple pathways to understanding. They're particularly beneficial for students who struggle with traditional abstract instruction, including students who have been performing as low achievers, students with learning disabilities, and English language learners. By building a strong foundation in conceptual understanding through manipulatives, students are better prepared to tackle more complex mathematical concepts in the future, including those in algebra and beyond. In grade 1, instructional time should focus on 4 critical areas: developing understanding of addition, subtraction, and strategies for addition and subtraction within 20, developing understanding of whole number relationships and place value, including grouping in tens and ones, developing understanding of linear measurement and measuring lengths as iterating length units, and reasoning about attributes of and composing and decomposing geometric shapes. The math tools we will share in the next few slides reflect supporting these 4 critical areas. Unifix cubes. These interlocking cubes are excellent for building, counting, comparing, and creating patterns. They can be used for various math activities, including representing numbers, adding, and subtracting. Unifix cubes provide a tangible way for students to explore numbers and their relationships. They can be used to represent numbers, count, and understand cardinality, the quantity of a set. Students can physically build groups of cubes to represent different quantities, helping them grasp the concept of how many. In first grade, Unifix cubes are excellent for understanding place value, particularly when working with tens and ones. Students can build a stick of 10 cubes to represent a 10, and then combine these sticks with individual cubes to represent larger numbers. This hands-on approach helps students visualize and understand the meaning of the digits in the tens and ones place. Unifix cubes can be used to model addition and subtraction problems, making abstract concepts more concrete. Students can physically combine or separate groups of cubes to represent the actions of adding or subtracting. The visual representation adds an understanding basic addition and subtraction facts. Unifix cubes can be used to create patterns, both visually and numerically. Students can sort cubes by color or other attributes, fostering organizational skills and visual discrimination. Unifix cubes can be used to measure in a hands-on way. Students can use them to create models of shapes and objects, reinforcing geometric concepts. Base 10 blocks, the ones, the tens, and the hundreds, are essential for teaching place value, understanding number representation, and performing addition and subtraction within multi-digit numbers. The first graders are really going to focus on using the tens and the ones. They allow students to physically manipulate objects to develop understanding of these concepts. Base 10 blocks help students grasp the concept of place value by physically representing those numbers. Again, we're going to focus on the ones, those unit cubes that are yellow in the top picture. And the tens, sometimes teachers call them longs or rods. They're green in the top picture. And just for your understanding, of course, that blue flat is 100, but we're really not going to use that in first grade. Focused in first grade on the tens and the ones. But just know later in other grades, students are going to focus on the hundreds, the flats, and there's even 1,000 cube, which is not pictured. This visual aid helps students understand that the position of a digit in a number determines its value. Students can physically manipulate these base 10 blocks to perform addition and subtraction, making the concepts more concrete and easier to understand. This allows them in later grades to see the process of regrouping or trading when adding and subtracting, which is crucial for developing deeper understanding of arithmetic. That 100 chart, a great visual representation of numbers from 1 to 100 arranged in a grid, offers numerous benefits for our young learners, particularly in developing number sense and mathematical skills. It aids in counting, skip counting, understanding patterns, and visualizing addition and subtraction strategies because we can model them on the 100 chart. Developing counting and number sense, counting to 120. Of course, this chart just goes up to 100. There are 120 charts. These charts make it easier for children to understand the sequence of counting and count effectively. This chart can be wonderful for skip counting by twos, having students maybe have their own copy of the 100 chart and color in green all of the areas they land on by skip counting by twos. Maybe having them skip counting by fives, that's appropriate in first grade. Maybe they're using a red crayon and coloring all the squares they land on with skip counting by fives. Skip counting by tens, maybe grab another color, have them color all the numbers they land on when they skip count by tens. Are they overlapping any numbers with the twos and the fives? I wonder why. So having them make these discoveries. The structure arrangement of the 100 chart helps children recognize numbers and their place in the sequence. The chart highlights patterns within the numbers, such as the repeating digits in the tens place. We can look at that second row and notice that almost all of the numbers have a 1 in the tens place. We get to the end of the second row, and then it changes to 2. And then in the third row, all of the numbers or the digits in the tens place start with a 2 or have a 2 in them until we get to that last spot, and then we see a 3. And that pattern is continuing and talking to students and asking them, why is that? The 100 chart allows students to visually connect numbers and understand their relationships, such as how they relate to each other in the rows and in the columns. The hundreds chart is great for helping students with addition and subtraction because it can be used to visualize addition and subtraction strategies, such as that counting on strategy or counting back by a certain number. Also, by working within the 100 chart, children can develop an understanding of place value as they see how numbers are composed of tens and ones. This chart can be used to solve various math problems, such as finding a number that is 10 more than a given number and 10 less than a given number. At first, students are going to really physically need to be touching the chart to figure this out. But at some point, and it might be later in second grade, but at some point mentally, they can just do the math in their head. Oh, 3 and 10 more. Oh, I can just visualize 13. 13 and 10 more. Oh, I can just visualize 23. At some point, after having a lot of experience with the 100 chart, students will be there mentally. Using the chart encourages critical thinking skills as students analyze patterns, make predictions, and solve problems. You can get great large teacher version or class version, I should say, pocket chart, which is invaluable of the hundreds chart. So it has a little place for all of the digits, all the numbers from 1 to 100. That can be at a center. Students can be building the chart. There's so many wonderful activities and experiences that children can be involved in with this chart. Measurement math tools. These are the grade 1 standards in the area of measurement. Order 3 objects by length. Compare the lengths of 2 objects indirectly by using a third object. Is it shorter? Is it longer? Express the length of an object as a whole number of length units. Maybe I'm measuring a pencil lining up the plastic teddy bears, or maybe I'm measuring my desk using the crayon. So these are non-standard measurement tools. Understand that the length measurement of an object is a number of same size. So it has to be the same unit we're using, whether it's plastic teddy bears or the same crayon or the same paper clip. Understand the length measurement of an object is a number of same size length units that span it with no gaps or overlaps. You'll want to provide non-standard measuring tools for your first graders, like plastic teddy bears, crayons, paper clips. And here's another measurement standard. Tell and write time in hours and half hours using analog and digital clocks. To support the analog part of that standard, a demonstration Judy clock, which you see the large class version at the top of the screen, and a class set of Judy clocks, so every student can have their own, is essential. Continuing the work from kindergarten with 2D and 3D shapes in first grade provides numerous benefits, including enhancing spatial awareness, visual literacy, language development, and foundational, probably most importantly, math skills. It also promotes problem-solving abilities and cognitive development. Further, it helps children understand the world around them by identifying shapes in their environment and developing a sense of space. So students are going to be recognizing and distinguishing between flat, two-dimensional plane shapes and 3D solid, three-dimensional shapes. This will be helping children develop spatial reasoning, which is the ability to understand and interact with the space around them. Learning about shapes improves visual perception and the ability to interpret visual information, which is crucial for early childhood development and later academic success. Also, these kinds of experiences are going to be supporting language development. Students will be describing the shapes, talking perhaps about the vertices, the sides, the edges, and their relationship to each other encourages language development and vocabulary expansion. Shape recognition, analysis of those characteristics of shapes like vertices, edges, and sides, and understanding lay the groundwork for more advanced math concepts in the geometry domain in later grades. Manipulating and visualizing shapes helps children develop problem-solving skills as they learn to visualize, deconstruct, and reconstruct new forms. Children can learn to identify shapes in their everyday environment, finding solids in their classroom or cubes in their classroom or on their walk to the cafeteria. What plane shapes do they see? What solid shapes do they see? Here are the top 4 teacher comments that we get from teachers on why they don't use math tools. And to be honest with you, this is mostly from upper grade teachers. I think most primary teachers see the benefit of using math tools with their students. Number 1, we don't have time. Number 2, I don't know how and why to use them. Probably the most popular is number 3, my students can't handle it. Number 4, I didn't learn that way, so why should my students? Hopefully this math workshop helped you with the second comment, providing the rationale for the how and the why. We respect that you are the professional in your classroom, and it's your decision on how to provide the best instruction possible for your students. We want you to consider for the comment number 1 that we don't have time, that your students' time spent truly understanding math concepts through the use of math tools leads to deeper understanding, memory retention of the math concepts because they really understood the math idea. And if students don't understand why they're performing certain math steps or following procedures, it's very likely they will forget what they were doing and how they were doing it. Meaning next year, they're going to have to relearn what they learned in the previous year because they didn't remember it, they didn't recall it. It also leads to them making a lot of mistakes. So our gentle response to the first comment is, how can you not take the time for real learning and understanding? We encourage you to watch this math workshop again and share it with a colleague. We know that teaching is so much easier when we have the support of working alongside awesome colleagues who are committed to collaboration, sharing our journey in the world of teaching together. For the third comment, my students can't handle it. The next slide will offer tips for successful implementation that teachers have used. And for the fourth comment, I didn't learn that way. Why should my students? Our response is that research shows that most learners, and that's adults and children, learn best through tactile, hands-on, and visual experiences, especially in mathematics, where the concepts tend to be very abstract. Oh, and here's a bonus one. Sometimes teachers say number 5, they don't say this so much in first grade, but later grades, they can't use the tool on the end of the year test, so why should I provide it during the year? Well, this is true in most cases, in most grades where there is that big end of the year test. But we have to remember that through using the math tools throughout the school year, students will have deeply learned all about the math concepts so that then when they take that end of the year test, if there is one, they're going to be successful on any type of assessment because their learning has been internalized. Here are some tips for successful implementation of math tools from teachers. Number 1, give students explore time every time. It's just maybe 2 minutes. Set a timer and tell your students we're about to use this object as a math tool. But first, I'm going to respect you. Here's your 2 minutes of explore time. It's your time to check out this tool before we use it as a math tool. You will find that students will appreciate this explore time to see what the tool looks like, feels like. Can they kind of gently roll it? What does it feel like in their hand? And this will allow them, then when it's time to focus during math time using the tool as a math tool, they're ready to focus. Number 2, setting clear expectations. Before ever passing out a math tool, share this is how it can and cannot be used. For example, in upper grades, when geoboards and rubber bands are being used, sharing with students, those rubber bands will not go flying across the room. And if they do, the consequence is that whoever chooses to do that activity of flinging the rubber band across the room will lose the privilege of using the geoboards and rubber bands that day. Students do not like that. They want to have their hands on the tools. They don't want to just be sitting there watching their friends who get to explore with the math tool. Number 3, model usage. This is how we're going to use the tool. Number 4, consider options that work best for your budget, your space, yourself, and your students. Do you want to provide math toolkits or toolboxes for each student where the items inside rotate over time and students have choice? We have seen these being used very successfully in classrooms across the country. You could have a classroom helper job that student restocks the math toolkits regularly for you. Maybe you swap out some of the tools that are in it depending on what the mathematics that your students are engaged in. Or would it work better in your space and with your budget to have a math tool area in your classroom with math tools and plastic bins? Possibly consider having table group or individual student amounts in baggies. Whatever works best for your activity, your space, and your students. Our hope is that you found this first grade math tools, math workshop very supportive. If you want more support, I invite you to join our first grade community for a year of support. You can join for a year, you can join for a month. It's up to you. When joining this private community with other first grade educators, you will gain access to a collection of math workshops similar to this one, which take a deeper dive into understanding the first grade math standards and the math tools that you will want to provide for your children. Monthly throughout the year, you will receive engaging hands-on activities using the tools that we talked about in this video. Lessons, games, word wall cards, and so much more to support your first grade math standards. You can find out more information on how to register to be a part of our first grade math community on our website. Go to the resources page and click on your grade level. Thank you for your time, and we hope you have a great year.